further ado, can I please now hand over to Don and his talk about all things outside of the ham bands. Thank you.
We're going to let you know.
No, make sure you got the rotten tomatoes after, isn't it? Just while we're on the subject of D-Day, which has come up, it might interest you to know that with all of that equipment that was being ferried over there, they actually had 3 ships, 3 large, they were the large landing craft that they had kitted out as air direction ships. So all the air traffic that was going on over there was all directed from 3 ships that were moored off the French coast. Those ships were obviously radar, equipped with radar, and on board were people listening to the Germans. So people actually listening to the German communications that were going on along inside, and that was being fed back to the troops on the ground. Yes, a lot of people still lost their lives, but there was intelligence being gathered even as we were storming the beaches. There is a bit of film on the Imperial War Museum website which shows you one of the ships being under trial. Right, back to this evening. Where am I coming from? I started listening to the radio when I was about 13. Yeah.
Did they have radio back then?
No,
Crystal set.
Crystal set, yeah. I was listening to the family radio, tuning up to the bottom end of the medium wave band and finding all some funny sounds up there, bleeps and squeaks, which was Morse code, although I didn't know it at the time. That's what got me interested in it. So I then ended up going into the Navy and spent the rest of my life listening to radio. I did it for a living. My father-in-law once said to me, people who listen into other people's phone calls should be taken out and shot. And I said, well, I'm very sorry, Dad, but it's paying the mortgage. You know, and I've done it for a hobby as well. So 30 years ago, 40 years ago, if you wandered outside of the HF ham bands, and I'm going to stick to HF tonight, because if I took on VHF, UHF and SHF, we'd still be here next week. So I'm just going to stick to 0 to 30 megs tonight. Yeah, 30 years ago, 40 years ago, as many of you are probably aware, if you wandered outside the ham bands, you only had to move the tuning dial a couple of kilohertz, and you'd hear something else, some other noise. Because there was loads of commercial traffic, there was aviation traffic, there was military traffic, all of which you could actually decode if you had the right kit. The problem that you had if you did that is that you couldn't really get hold of the kit, because what was being sold to you wasn't that good enough for the job. You had an amateur bands receiver, and that's what your receiver did. It tuned the amateur bands. So you had to go out and buy a communications receiver or a general coverage receiver. The offerings from Sony and Panasonic and all the other ones were okay. They did SSB, but the filtering wasn't that clever. If you had deep pockets, you had to go out and buy something that was ex-military or ex-commercial, which probably took 2 of you to lift to put onto the table. But you had some decent filtering in there. When I started doing that, I ended up with an AR-88, which some of you will remember. But it nearly broke my back to lift it up onto the table. But suddenly I could hear all sorts of funny things. At work, I was using all sorts of stuff, from Roden Schwartz, Raycool, all the really good kit. Anyway, what do you need to listen to this stuff? You need a receiver. You've all got a receiver. You may not have one of those, but you've got a receiver. You need an antenna. You've got an antenna there. You don't need a particularly good antenna. You don't need to cut it. You need a fairly wideband one. A long wire would do with a good earth. And these days, if you're going to do anything with data, you need the laptop. Because back in the 1980s, the PC and the radio got married, and they've been stuck together ever since. To the certain point is that, you know, they're inseparable now, and you get a radio on a chip. We're very well off these days, because what the manufacturers do of our kit, the amateur radio kit, what they're building is they're building an HF transceiver. That's what it starts out in life as. They're not building an amateur bands transceiver, they're building an HF transceiver. They then put in a few stops to stop you transmitting outside the amateur bands, which if you pay somebody 20 odd quid, they'll take off for you, and you've then got an HF transceiver. I've done it on a 7300. I haven't done it myself. I've paid somebody to do it because it's about that size, you know, a little field of diodes. And suddenly you can transmit anywhere you like. I bought my latest rig from Martin Lynch, and it came with a receipt and a big red stone said, please note, you are responsible for keeping your transmissions within the amateur band. But I can get on 5 megs. With the advent of software-defined radio, all of these rigs, a lot of them, have got things like waterfall displays, which are very, very useful, because now we've stopped using these to identify the signal, and we're using our eyes. And you can actually tell a lot from looking at a waterfall display. How I wish we had these 30, 40 years ago at work. It would have made life one heck of a lot easier. So you've got your rig, you've got your antenna. Now I'm going to commit the cardinal sin and start talking about web-based receivers. Because we've got a whole range of receivers out there. There are numerous receivers dotted around the globe. And there are 2 main websites which you can go to. There are others, but what I'd like you to think about, if you're in your shack and you've got an antenna, you've got a receiver, you connect your receiver to your PC by a USB cable or by an interface. And off you go and you do your data modes or whatever you're doing, or you're listening to something and decoding it. All you've done by using a web receiver is you've extended that 2-meter bit of cable, that USB cable, to 2,000 meters. 2 kilometers, 200 kilometers, 2,000 kilometers. Because at the other end of that is a receiver with an antenna. That's all you've done. You're still using a receiver. Might not be a black box with knobs on, but you are using a receiver. All you want is the audio. And it does open up another world. There are receivers around the world, you can't hear it. I'm going to show you a fax signal later on from Japan on 16 megs. Now I can't hear 16 megs from Japan on most days, especially recently. So the first one, WebSDR. When you jump on it, it presents you with a whole list, and this is a scroll down list, masses of receivers all around the world, tends to be focused on the amateur bands. But the first one, right at the top, is in Holland. It's at the University of Twente in Skade in the Netherlands, and that's 0 to 29 megs. The others are varying. But to save going down the list, it also gives you a nice little map that you can click on any one of these and it will tell you where it is, double click it and it will take you to the web page. And the interface that you're working with is something like that. Look familiar to some people? Yeah, of course it does. On there is the one up at in Cheshire, at the Hat Green. Yeah, that's there. And you can play around with it and take the audio out of it. The other one, Kiwi SDR. I know some of you are probably quite familiar with this. Some of you may not be. Kiwi SDR, again, same idea, top-down list, and you've also got a map that you can zoom in, and that's the interface. Again, with the waterfall display. Kiwi SDRs, they've all been developed by radio amateurs. Just we'll look at this display a bit later on. This box here, if you are familiar with this display, if you click on that, you get a whole range of decoders come up. All people have written software to go with this, everything from RTTY to some of the more fancy modes. There's all sorts of things on there, even Morse code. But the Morse decoder is not very good. And you can zoom in and tune up and down. Any questions? Right, we're going to look at different types of signals. And I sort of base this on modulation. So think back to when you did your basic, the first modulation is on-off keying. The carrier is switched on and off in a predetermined pattern. We call it CW, but it's not continuous wave, it's on-off keyed. It's switched on and off. Continuous wave is just a carrier. Well, that's me being purist. Amplitude modulation, where the modulating waveform varies the amplitude of the carrier. And then we've got frequency. I didn't know General Custer would come in. And phase modulation. Now I'm going to give you examples of these, where some of these signals are tonight. That's it. It's going to be one of those. There are signals on the HF band that use all of that in one signal. It can be amplitude modulated, frequency modulated, phase, and of course pulse modulated as well. But you know, it could be a bit tricky looking at that. I'm thinking of over-the-horizon radar. The noise, the click, click, clicks that we hear in the hand bands. They are very, very sophisticated.
Woodpecker.
Eh? The woodpecker. Yeah, exactly, the woodpecker. But you've got a pulse, and then on top of that pulse, you've got some FM, and then on top of that FM, you might have a bit of phase. Right, on-off key signals. Let's have a quick look. Well, the first ones, of course, are time signals. Now, time signals are very useful because it's very useful to actually calibrate your receiver with. Our very own MSF up in Anthorn in Cumbria on 60 kilohertz, the accuracy of the RF carrier is something like 2 parts in 10 to the 12 hertz. It's some ridiculous. It's as good as having a laboratory-based carrier. This guy, 77.5 in Germany, he uses on-off keyed and phase shift keying. Very accurate. Anybody that's got a radio control clock in their kitchen or something like that is probably driven by that. The Russian one. Eh?
That one does it?
Yeah.
That picks up off Germany.
Yeah. The Russian RWM, there are other Russian ones. Again, very accurate. And there's one in Japan. And there's loads. I've got a book here which I shall come to later, World Radio and TV Handbook, and there's a chapter in the back which lists all the time signals of the world.
I thought 996 was WWV in
No, WWV's on 5, 10 and 15 megs.
yeah.
Not 996 is...
Yeah, that's pretty close to it. Isn't
yeah.
it?
Yeah, but it's not... you can't be... Well, these are spot on, you know. This is... Don't know if you can hear that. It's not that loud. But that's MSF, just a single tone. If you go log on to the National Physical Laboratory, there's a little PDF file on there and it will tell you how to work it all out. But you need to get into binary coded decimal to actually start working out how it works. So, Morse. There is not a lot of commercial Morse around anymore. In fact, it's virtually all gone. Maritime have gone upstairs. There's no Morse used in aviation. Military, well, you won't get any no NATO military Morse, apart from the French. But this guy is a beacon. This is Israeli Morse. This is Haifa in Israel. He's got two frequencies, 6607. He goes all day long like this, 4x, about 20 words a minute. Occasionally he goes into traffic and he'll send you a bit of traffic. I'm using a CW decoding program here, which will decode it for you. And he sends 5-figure traffic. And that's about it, apart from this next one, which is the French military have radiated signal on 3881 and 6825 nearly 24 hours a day. It's also linked to the French Amateur Radio Club, and that's why they do it. It's for amateur radio training. And but he runs at 24 words a minute.
Yeah,
So
a little bit fast.
it's a little bit fast for some people. But what actually throws you, if your Morse is good enough, is every so often he puts in a group of punctuation symbols or figures, which can throw your brain. This is a little Morse decoded program, and it will just... If you tune around, you will find some Russian naval Morse as well. The Russians are still using a bit of naval Morse. And there's loads of websites which will tell you all about it. But they use cut figures and all sorts of funny things. Now, for those of you that are really interested in learning Morse, this is one I found quite recently, and I did a bit of research on the web. It's very slow, it's about 5-6 words a minute, and he just sends the same word about 20 times, then he changes the word. 5345.8. So anybody who's thinking of learning Morse code, have a listen out for this. And if you tune around 5-6 megs, you often hear beacon signals for whatever reason, and they're fairly slow. Now he's changed his tone. think this is about, yeah, he's sending it at about 13 words a minute, but it's long gaps. And he just repeats it over and over again. Good one for you. But he's not always there, but you might find him. So that's on-off key, on-off key. Basically, time signals, CW, you'll have to look out for it. There is some other CW you can listen to though. Right, just let's remind ourselves about AM. If I use amplitude modulation and I put a single tone, the signal I will radiate will be just that. It will be the carrier in the upper sideband and the lower sideband. With that, that's a 100 hertz tone. If I radiate speech between, say, 300 hertz and 4 kilohertz, I'm going to radiate a complex waveform, a whole band of frequencies. And the two sidebands are going to mirror each other. And you can see this very clearly from your waterfall display. And this represents a broadcast carrier, AM broadcast. Very old system, right back to the days of AM broadcast. So, AM broadcast stations, that's where they still are. The people that are still using AM broadcast, everybody's still broadcasting. Everybody said, no, we're not going to, broadcast stations are going to go off the air. We're all going on satellite, we're all going on DAB, we're all going online. But if you tune around on HF, there are still plenty of broadcast stations, pirate stations as well. So those bands have stayed the same. Interestingly, with the conflicts in Europe, Ukraine, and in Gaza, the BBC reactivated HF broadcasting, AM double sideband. They daily transmissions to Ukraine on 15 megs and 9 megs, and they've got a medium wave service at 3 o'clock in the afternoon to Gaza, half an hour on 639 kilohertz in the medium wave. How can you tune that in? Right, you can't get 639 kilohertz in Paignton in an afternoon. If you go online to Cyprus and find one of those web SDRs, you'll hear it. There's nothing there, and then all of a sudden, 6:39, up comes the chimes of Big Ben. And somebody says, this is the BBC Arabic service, in Arabic, obviously. Half an hour broadcast news for people in Gaza. And that's been going for about 6 months. So when all the mobile phones and the things go down, what do? They go back and get back the old HF broadcasting. So that's what it looks like. That's 0 to 30 meg. So broadcasting is spread out right across the spectrum. Again, it's useful to use because they're using fairly good transmitters. So if you want to line up something, you know, a BBC transmitter, World Service transmitter, or Voice of America, any one of those broadcasters, it's usually a good lineup. So what does it look like? Well, there's a few shots here of different radios. These big, thick carriers here is shots of an AM broadcast. There's another one there. Another one there, tuned to 11675. So let's have a look at one. So this is the start point transmitter down the road. BBC Radio 5 on 693. 2 sidebands with a carrier in the middle. Notice how sharp it is. No splatter. They're very well engineered transmitters. The audio I'm showing over here, it's frequency on the y-axis, time on the x-axis. And that is a blow-up really of what you're seeing there. If I just move this along a little bit. Oop. Sorry about that. I thought I should have a playback bar on here. I can't find it. Bear with, chaps. What you'll see in a minute, hopefully, is you'll see I will select the lower sideband and then the upper sideband in that green area, and you'll see that the picture over there won't change. Just the power level will go down slightly. This is one of the things of doing this. You do this on a computer at home or a desktop, then you put it on a laptop and you can't see the bits that you've put in. Right, let's move on. AM. Right, now here's something a bit different. Not the sort of thing you normally find. This is on 837 kilohertz. It's the BBC transmitter, the BBC Asian service, and tucked alongside it is a beat Morse beacon, right in the middle of the medium wave broadcasting band. And that's the beacon for Cranfield Aerodrome.
Normally a lot lower in frequency, normally down around 3 to 400, something.
Yeah. So I did a bit of research, and if you look up the International Civil Aviation Organisation, they say you can have an airfield beacon right up to 1,750 kilohertz, 1.75 megs. So Cranfield Aerodrome up there in the Midlands has got this little beacon. That's rather a funny looking thing, where you can see up there the audio's coming out of it, CIT in Morse. And I'm tuned using AM. So you've got the two examples of AM there. You've got AM with a tone, a key tone at 400 hertz, and AM with a speech transmission. Now they use a 400 hertz tone to modulate the carrier, which is not very good to hear because it's quite low. So if you carefully manipulate the tuning controls, you can, what I've done here is I've offset the tuning, so I've centered the carrier about 1 kilohertz, and you can see the carrier there with the tone either side of it. And you can play around. These web SDRs are brilliant for this, because you can play around with filtering, and you can actually filter out one sideband so easily. I'm going to come back to the beacon signals in a moment. But like you, I thought, what's a beacon doing in the middle of a medium wave broadcast band? because it's normally much lower. But and again, if you're learning CW, these beacon signals are quite useful.
I think if I remember rightly, the NDB extra was about 347, wasn't it?
Yeah. Right, a few pictures here. BBC Radio 4 long wave on 198 kilohertz. What's AMDS? Well, it's an AM data system. If we zoom in on the carrier, we find that there's something going on the carrier. So I'm right in on the carrier now. That's where the two sidebands end, but there's obviously some sort of keying going on the carrier. And it's a phase shift keyed signal, very small, very narrow band phase shift keyed signal. And if there's a couple of pictures on the web, that's what it looks like when you blow it up. It's actually a time signal. And it sounds like that, a little warbling tone. You can actually tune it out. What it is, in fact, is the radio teleswitch. It's all to do with controlling domestic economy 7 heating systems and the like. It's radiated by 3 transmitters in the UK, Droitwich, Westerglen and Birkhead. Basically, it's transmitted by the BBC and it controls your...
Originally that was 200 kilohertz.
198 was originally with 200 kilohertz, yeah, it's 198. Why is it still with us? Because they're not buying smart meters, that's why. The BBC wanted to switch off long wave and medium wave April this year. And it's still there because they won't turn it off. The latest I've read online is that they hopefully will switch it off by April 2025 when everybody's been switched over to a smart meter.
Oh, well. Isn't there some sort of legend that they're down to their very, very last valve that fits this particular transmitter?
That's
and
right.
If that valve fails, that there will be no more.
That's the problem, is you've got this lovely big transmitter in Droitwich, which is poking out about 500 kilowatts, and they can't maintain it because they can't get the bits. It was built in the 1930s.
It's a huge, they have one valve
One
left.
valve left. It's a, you know, it's a sort of a...
It's absolutely huge there.
Yeah, I mean, it's a monster of a transmitter.
I used to pass that every day to work.
Yeah, I'm sure you did,
I
yeah.
think the masts are like 300, 400 foot high, they're massive.
Oh, a huge, great, yeah, I mean, if you go...
Are they 750, yeah?
When you drive up the M5 and you see the Droitwich transmitter... I mean, BBC Radio 4 long wave, it's very useful. I've actually picked it up on a ship anchored off the Suez Canal
Good.
in the middle of the night on a bit of wet string. So, yeah, it's there. Anyway, that's what... So, don't dismiss broadcast band. You can go snoozing around the broadcast band. You can find odd anomalies in there. You will find data transmissions in there. They shouldn't be there, just the same as they shouldn't be in the amateur bands. But anyway, that's what's going on there. So, and that's why we've still got long wave. Now, anybody's thinking about learning Morse, these might come in handy. These are an old system, and they sit between 190 and 530 odd kilohertz, but as I found out recently, you can get beacons up to 1750. This goes back to the days before we had GPS, before we had clever navigation systems. You had radio beacons, marine and aero beacons. Every airfield has one. Peter, I know, remembers doing DF on marine beacons. That's how you navigated when you were in the middle of the ocean. These are very simple signals. That's what they look like. They're all AM. They have a carrier keyed with a tone either side. And this one is, I don't know if you can hear that, probably not very well. It's only 400 hertz tone. YVL. YVL is the Leonardo Westlands factory in Yeovil, because they've got an airfield. This is on the Western Supermare SDR, YVL. And again, you can fiddle around with the tuning to get out a higher tone. But that's, and there's loads on there. And there are a bunch of people out there in the world who actually listen to these for a hobby. And they'd be excellent.
Local one is Berry Head.
Big, yeah, 112.5 megs, yeah, Berry Head, same thing.
PhD.
Yeah, BHD. They slowly but surely are being, they will get rid of them eventually, because most aircraft now have a GPS system.
There is a difference though with the Berry Head one, because the Berry Head one is actually a VOR, which actually gives you a directional signal,
Yeah.
which the NDB that Don's talking about doesn't.
I'm just going to see if I can make that audio a bit better. YVL. That's quite a strong one. So what I've done here is I've offset the receiver tuning and I'm just pulling out one sideband and you can hear it a lot clearer. YVL, got that? Right, amplitude modulation. Of course, what we've got is HF SSB. What's out there on HF SSB?
Proper radio.
Apart from lots of people rag shoeing on 80 metres. Let's see what I wrote down here. Right. Firstly, maritime weather forecasts at MF. Most 2 or 3 Coast Guard stations in the world still chucking out voice weather forecasts. Again, all the frequencies are published. But for some reason, the marine world has gone over to using satellite comms in a big way. But the aviation world is hanging on to HF. So you still get VOLMET broadcasts, which are airfield MET broadcasts. And you'll also get airways control, still on HF. Now there's a plethora of instruments in a modern airliner. They don't need to talk to anybody, really. But they're still talking to air traffic control on HF, as we shall hear in a minute. It's belt and braces, I think. You will not now find much military in the clear. Very, very rarely. You may get 1 or 2 transmissions from Plymouth on the air safety net on 3924, but if they're going to use HF, it will be enciphered anyway. It will just be a noise. So military, you can forget. Occasionally you will hear a helicopter stooging about, and it'll just be talking about basic stuff. But the RAF maintain a Volmet service. This is what it sounds like.
This is Shannon Volmet. Shannon Volmet. Forecast. Round Fiumicino. Forecast. Round Fiumicino. Valid from the 28th at 1200 until the 29th at 1800. Wind 240 degrees, 13 knots. Visibility 10 kilometers or more. Cloud scattered at 3,000 feet. Becoming between 1700 and 1900. This is Shannon Volmet. Shannon Volmet.
Funny name for a lady, isn't it? Shannon Ballmer.
Shannon, Volmet. Shannon is a radio station in Shannon, in Ireland. And they poke out that broadcast on various frequencies throughout the HF spectrum. That's the what they're doing. And 5505 is a good one. There's one on 3 megs, 8 megs, 13 megs. You can pick them up, set your receiver up to for upper sideband. It's a disjointed voice because it's all computer generated, you know, and it goes round. They give so many forecasts, but it's a good signal. The other one out there is another disjointed voice.
Military 1 times Lot 3 information broadcast. Pacific at 1500 wind 240 degrees 7 knots. Military 1 times Lot 3 information broadcast.
What did she say? This is military 1 time slot 3 information broadcast. She said then Keflavik and gave the wind. It's dreadful in terms of quality. And I don't know if there are any RAF pilots actually listening to it now. But you've got slots. I think you've got 7 slots throughout a 2 or 3 hour period, and they just, same thing, give off various airfields forecasts. And then you get this. Now what I've done is now Shanwick is based in Shannon, and it's a 2-part call sign. It's Prestwick and Shannon put together and becomes Shanwick. And these guys control the air traffic over the North Atlantic. So if you look up any air traffic publication, you'll see that it's like looking at a road map. It's all very, very carefully controlled. And they talk to them on HF.
Thanks, just to confirm you take copies of VHF 128.6. Thank you. Sound radio. Channel 654 PLC internet. November 554, Golf Papa Shell, Canadian second to Golf Shell, make 10021 at 30 West, contact Gander Radio on 132.9er1 with the secondary of 11279er. So call check coming up now, somebody. Small correction for the number 554 Golf Papa. The Gander primary is 1329R1. Show. Thanks, show radio. Break, Lufthansa 438, show. Thanks, Lufthansa 438. Response for you from ETC. They advise that your ADS is still working for automatic reports. Show.
That's the kind of chat you're going to get on airways control. Lots of ATC type of talk.
Your ADS is still working for the automatic reports. Show. Thanks.
So you notice how quickly they speak. Pilots talk very, very quickly. They do, because they're very busy. Pilots will talk, just go to an airfield and listen to the air traffic control circuits with airfield. Half the time they know what they're going to say, the guy at the other end knows what he's going to say. What can you do with that? Okay, you have a listen to it, and then what you do is you go on to Plane Finder and you find out where Lufthansa 438 is, and you find he's stuck out here in the Atlantic. So if you're sitting at home and you're listening to this on your little antenna down here, you've just about heard Lufthansa 438 there, and you can see where he is. That was about 2 weeks ago, I heard that. So yeah, it's out there. I mean, hours will go by and you'll hear nothing on the frequency, but you can see all of that within 5 minutes. You've got 2 other frequencies to listen to. So, and the 2 other things they mentioned in there, they've got an HF system, a data system, which we'll look at a bit later on, that tells the world where they are. They've got ADS-B system, which produces all this display that you can look at online. You know, and they're still using steam radio, you know. You know, it's still using HF, AM, SSB, but there you go. Right, frequency modulation. Anybody got any questions about broadcast stations or HFSSB? That was 6547. If you play it back and you listen to it, when an aircraft calls, he will usually announce what frequency is on. You know what frequency you're on because you've got it on your receiver dial. But yeah, 6547. Again, frequencies throughout the spectrum. But before we finish, I'm coming on to where you're going to get your information from. So FM, if I key a carrier with an FM tone, one single tone, I'm going to get a spectrum like that. If I key it with a complex waveform, i.e. speech, I'm going to get something like that. Now, I'm not going to dwell on FM. There is FM out there, but the only FM you're going to be able to do anything with is probably 11 meters, UKCB. That's FM. Some of the FM stuff, the ionosons and some of the scientific stuff on HF, you might be able to identify it from what it is, and that's it. There won't be any data on it that you can get out. But there is a form of FM that we can do something with. Digital FM, which we know as frequency shift keying. So we're now moving into the world of data modes. And this allows digital information, which is a 1 or a 0, to be transmitted over a radio path. So quite simply, I've got a digital pattern An on, a 1 is one frequency, and off is another frequency. So I could send Morse like this, on, off. But instead of switching the carrier on and off, I'd be moving the carrier from one place to another. And I'm sure you'll all know this sound when you hear it. It's RTTY. I don't know if you can make it out, but you can see the signal I'm tuned to here, and you can see the carrier there, and then he starts keying and he's just shifting his carrier. The shift he's using, that's the distance between one frequency and another, is 850 Hertz, and the speed is 75 bodes. Now, if you don't know what a bode is, it comes from Mr. Emile Baudot, who invented this kind of telegraphy way back at the turn of the 19th and 20th centuries. That's where the term bode comes from. What it means is it's the speed that the carrier is changing. It's the telegraphic speed of the carrier. It's not your data rate, it's your telegraphic speed. So the carrier's doing 75 bodes. It's probably the most misquoted term in radio, depending on which book you pick up. You know, they'll have a, because once you start getting onto more complicated carriers, baud rate and bit rate, which is your data rate, diverge. It's only when you're using two-state carrier, when you're shifting from one frequency to another, you've only got two states, that's when baud rate equals bit rate. So what are we looking at here? Well, this guy is, he's still going actually, he's military, call sign PBB, which is Scheveningen Radio, Dutch Navy, transmits 24/7 on this 3 or 4 frequencies throughout HF, and he's sending a what they call a CARB, a channel availability rebroadcast. Basically, warships will copy this, and this is saying that there are frequencies available on 2 megs, 4 megs, 8 megs, 6 megs, 8 megs, 12 and 22 to partial traffic. And of course, all that will be encrypted. This is just in plain old Murray code. But the next one is provides us with lots of traffic, 24 hours a day. It never goes off the air. The German Weather Service transmits 2 schedules. There's 6 frequencies up there. They use the standard Baudot Murray code, shift 450 Hertz, speed 50 baud, and it just rolls on 24 hours a day. Always a good one to check out your decoding software with. So this is schedule 1. When he's not got traffic to send, he just sends this. The decoder I'm using here is showing you the actual pattern of the 1s and 0s. And you can see the stop bits in the pattern. That's the first schedule. The second one, and I took this on the lower frequency because it's slightly different. The 147 kilohertz frequency, this one up here, is a very narrow shift. It's only 85 hertz between the two tones. And this is the kind of stuff you're going to get. and it goes 24 hours a day.
I couldn't have some, do I? please?
Yeah, fine.
That looks very much like QR code.
It looks like a QR code, but it's not. It looks like a QR code. What I'm doing here is I'm using a raster scan. I'm scanning, these are ones and zeros, and I'm just scanning over the bits. One of the things I've thought about is that this is just giving you the flavour of what you can find out there. We can have a teaching on a Friday night on any one of these signals individually, where I can explain it in a bit more detail, but rather than getting down into the weeds this evening. Now, back in the 1990s, there was something called the Global Maritime Distress and Safety System brought into place, and part of it was the Navtex thing. And you can go out, if you've got a boat, and you can buy a little Navtex receiver, which will have these two frequencies fixed in it, and it will just churn out navigational warnings and metadata all day long. Those of you who might remember Amtor, anybody used Amtor? Remember Amtor? Right, Amtor was derived from something called SITOR, which is ship's telex over radio. Telex. Had two modes. It had a mode A and mode B. Mode B is the broadcast mode, and what this introduces is our first look at forward error correction. This is where you put some extra information into the signal to actually correct the receiver. So if you miss a character, it corrects it. This is a very basic system. It sends each character twice. So it sends one character, then another 3 characters, and then it sends the second character, that character again. So it gets 2 bites of the cherry. What it means is you get a much better print on a poor signal. And it runs at scheduled times, comes on with a carrier. You get a very, very unique phasing signal in a moment, hopefully. Like a little warble. And I'm using yet another piece of decoding software here called YAND. YAND stands for yet another Navtex decoder. I kid you not. The guy that wrote it, unfortunately, is dead. But it decodes this stuff, and it prints it out down there and stores it away for you. YAND is a brilliant piece of software. It's all free, because you can actually go in and tailor it to your own. Say you only wanted to listen to UK stations, you could tailor that, or you only wanted to listen to something from Area 1 or whatever. And what is interesting, if you set this up overnight on, say, 518 kilohertz and leave it, you get loads of traffic in the morning. If you've got DX Atlas software, which you see pictures of in Practical Wireless and Radcom, it will dump all the stations into that, so you can see how far you've heard. And I've done that, and I've got stations as far away as Israel. You know, there are another one out there. This is a bit of traffic. Again, this is a package called CTTY, which is a multi-mode decoder. There's our warble. And away he goes in traffic. This is Austin Radio. Remember OST, Peter? He's still on the air. And you're going to get stuff like this. What is interesting, when you see something on the news like the tanker hitting the bridge in America, go on a WebSDR, look at the Navtex traffic in North America, and you can read all about it. all the safety zones that have been set up and all that. You'll notice that the messages start with ZCZC, and it will finish in a moment with 4 Ns. That's the standard telegraphic start and stop message symbol. And a program like this, what it will do is when it's idling, when there's no there, it will often print rubbish characters, but this actually sorts it out for you. So if you're looking back through the traffic, and it goes on. But it does work on 10-minute schedules. So you might get nothing for about half an hour, and then you'll get, again, if you go online, all the information. Any questions on Navtex? It's very useful, especially if you've got a vote. One last form of digital FM is facsimile. Now, what this is still doing on air, I really don't know. Because I've got a fascinating fact here somewhere. Anybody like to hazard a guess at when the first facsimile transmission system was patented?
1951.
Okay, that's a start, 1951.
I'm going to go somewhere around in the 20s.
1920.
1920s.
I reckon it's going to be earlier than that.
That's right, Joe.
Alexander McBain in 1843.
That was done by
The
candlelight.
first public facsimile transmission system was opened between Paris and Lyon in France in 1865. This is before we had HF radio. And what they were sending by facsimile wasn't pictures or maps, it was sending copies of telegrams. And the idea of scanning something like that, black, white, was patented right the way back then. Amazingly. There is, I don't know if you remember, some years ago there was a television programme. The guy said, how does a washing machine work? How does a radio work? One of the things he did was, how does a facsimile work? I think it's a 1980s thing. It was when lots of the new high-speed faxes were coming in. And this was a fax. This was a fascinating fact. Sorry?
Was that Tomorrow's World that they?
No, it was a bit of a
How things work.
how things work. That's it. Yeah.
Twain's Wolf.
Eh?
Twain's Wolf, wasn't it?
He was on it, but
Fred Dinage.
he's somebody like that. He was, you know, and he was in a shed with an old leather jacket, old jacket on. You know, he's a typical. He's British, you know. But one of the programs he did was on facsimile machines.
Has it changed over the years?
Oh yeah, it's gone. It went digital in the 80s, you know. But this is analog.
When it was way back in 1836, I
It was,
mean, has it changed?
oh yeah, but this system, the HF system over radio, has been around since the 20s. So it uses 2 tones, 1500 hertz. It's an 800 hertz black, 800 hertz shift. Sorry, 1500 hertz is black, 2300 hertz is white, and it normally sends 120 lines a minute. Scans lines a minute. What does it sound like? Well, it will sound a bit like what we listened to last week.
almost sounds like a weather satellite.
Very similar.
You've got a Pringles fan
Same
now.
sort of system. And away he goes in traffic.
Picture will build up now.
That's nearly as bad as Spectrum loading up. Spectrum's got a bit more tune to it.
It's very, very easy to tune in on a receiver. All you do is just go up the sideband. If you look at the midpoint there, midpoint is 1900 hertz. You just offset your tuning by 1.9 kilohertz and you get that. So we've got a wind warning here, wind forecast for the 19th of March 2024. And this is poked out by Northwood, which is the Royal Navy. You can pick this up, it's all offline, all unencrypted. The question I asked is, well, why is it still there? You know, when you can go onto the internet and go and check and get a weather map.
You think a lot of it was reserving the frequencies just in
Yeah.
case.
You can't always get the internet where you are.
Yeah, but why, you know, but the marine world, which obviously are going to make use of this, are all on satellite. Inmarsat has kicked that off, you know. Anyway, that's, there is Deutsche Weather one does it as well, the German one. If you go online and you Google this, there is a document produced in America every few months, which gives you the up-to-date list of frequencies where you can find this stuff.
Don, there's one thing that's a bit odd with that, isn't there? Is don't you have to actually tune down on the frequency
Yes.
to actually receive it properly?
Yeah. What you do is, well, I said, if you think 1.5 kilohertz to 2.3 kilohertz, right?
Yeah.
The midpoint of that is 1.9 kilohertz. So what you do is you tune your receiver down, set it to upper sideband, so it's sitting on 1.9, and because depending on which program you're using, depending on which decoding program you're using, it will be looking for a 1.9 kilohertz centre frequency. It will be looking for 2.3.
Yeah, that's sorry, I missed that a minute ago.
Yeah.
You said it.
And this is an old system. Any of you watch the 1950s American police thing, and they say, I'm going to send you the photo of the criminal over the wire. That's the system they'll be using. Because it can send photographs, because you can either have black and white, anything in between, any frequencies in between, it's grayscale. The other thing it's very useful for is sending newspapers, or was sending newspapers for ships at sea. So there is still one left in the world. Sending, the Kyoto News Agency in Japan still pushes out a daily newspaper. As far as I know, it's the only one. But this is really the sort of thing that you go, if you're going to put it on, go and make yourself a cup of coffee. Because by the time you've had the cup of coffee, probably lunch and a bacon sarnie, you might have something there. Because it's, you know, goodness only knows why it's there, but it's still there. So, but facsimile does lend itself to Japanese characters.
You wouldn't want it to fade much, would you?
No. So, you notice how much slower this one is. It's half the speed. So you go and put the kettle on, and I can't read Japanese anyway. I've just done it for a bit of interest.
Still like to annoy your neighbours instead of putting heavy music on.
You have to make sure the windows are shut and you shut all the rest. But this is your sports news, page 5, page 6, 3rd of May 2024. So, a few weeks ago.
Manchester United 2, Manchester City 1.
and so on and so forth. Any questions? Yes.
One thing we haven't covered so far, when I used to repair tellies on boats in the docks in London,
Yeah.
they all had Decker navigation.
Yes.
That seems to have gone like all.
That's disappeared.
Yeah,
Nobody, Decker navigators are not on the air now.
yeah, because I got the impression it was various stations that all transmitted,
Yeah.
say in series, and then you found out...
That was basically three carriers that you triangulated and got switched. Yeah. No, Decker navigator's gone.
Oh, yeah.
Right, to finish off, because I know time's getting on, it's 9 o'clock. I didn't realise it was going to be this long, but never mind. I'm at the fag ends now. This is the binary sequence again, but what we're doing is we're not changing the frequency, we're changing the phase of the carrier. So what the receiver has to do to determine whether it's a 1 or a 0 is what the phase change is on the carrier. Well, obviously, in this carrier, it's 180 degrees. And the same idea there, just pictures. We're changing the phase of the carrier. And I've just got a couple of examples to show you, but before we do that, a lot of decoding software will represent a phase shift key transmission in a constellation diagram. 1 and a 0, biphase transmission. When you get it coming in, it will look a bit like that. Again, this is something I can develop in the club but I just want to touch on, if you've got 4 phases where you're only shifting the carrier 45 degrees, the carrier is moving to 4 discrete states. But you've only got a 1 or a 0. What do I need 4 states for if you've only got a 1 or a 0? Well, if you know your binary, 0, 0, 1, 0, 1, 1, 0, 1. That's the 4 states you can have in binary. So each change in the carrier represents 2 bits. So if I key this at 50 bodes, which means it changes between one of these states 50 times a second, my data rate is 100 bits per second. So I'm getting double the data for the same speed. Right, back to my aeroplanes. There is a system which churns along. All civil aircraft are fitted with it. It's got a whole load of titles. Most people know it as HF Data Link, and it sends out all sorts of traffic. Again, it's got a tone in the upper sideband. It runs at 1,800 bodes, but it can use all kinds of different modulation methods. So, and there's a worldwide network of ground stations that can pick this stuff up. So when you're up there in your airliner, you're not alone. So what does it sound like? I'm sure you've heard this stuff. Now, I'm on an SDR there, and I mentioned earlier on that you've got some stuff in there. Right, I've selected HFDL and it's being decoded. Sorry, I've got it. I'll just turn that down a bit. You don't want to listen to too much of that. Come on. Right, this is another decoder. Notice the constellation diagram. Right, to finish off, just the last thing with phase modulation is something called Stanag 4285. And you tune around HF, you will see quite a lot of this. Great big chunks, they're about 2.5 kilohertz wide, lots of noise. What does Stanag 4285 mean? Well, Stanag means Standing Agreement, and this is a NATO standardisation agreement for HF modem communications. It's quite a complicated signal. It's an 8-phase shift key carrier, and it runs at 2.4 kilobaud, which theoretically will give you a data rate of 7.2 kilobits. But you see, we know the vagaries of HF, forward error correction. There's loads of it in there, loads of it. Because fading, ionospheric disturbances, or as we've seen recently, complete and utter fade outs, not a good idea. So various frequencies. You know that. Being a military system, it will appear anywhere in the spectrum, even in the amateur bands. So,
I've heard that and always wondered what it was.
right, here we are. 8-phase, 8 PSK carrier, but all you're going to get is a load of ones and zeros. It's enciphered. He's running a long interleave, 1200 bits per second, but it's only enciphered. But you know it's tuned correctly because you can see the 8 phases. But our dear friends across the channel, the French, still use it unenciphered. What are they using? They are using an ordinary teleprinter. This is NATO Shipshire. 600 bits per second. This is Brest. The Brest Naval Centre runs 24 hours a day. Occasionally, if you leave that running, you might see a QSL on there for a message, or please repeat, or something like that. It's not a modern system. It was designed back in the 80s. Okay, that's the end of the talk. how do you find out about this stuff? Right, this is the bit. What I've done is I've printed off an information sheet. So I've got a, you want to pass those around, Ken? Just some ideas where you can go to on the web and books you can buy. All of the software you've seen tonight is free, downloadable from various sites. If you've got deep pockets, you can spend a fortune on this stuff. But all of that software you've seen demonstrated tonight is all for nothing, all free. All available at various sites. If you want to go looking at broadcast signals, I can recommend two publications. Firstly, that one, radio, is UK. That will tell you every radio station in the UK, comes out every year. The Radio Guide, it's published by somebody down in Plymouth. I can't remember his name, but he's been around for a while. Internationally, that one is your Bible for HF broadcasting. World Radio and TV Handbook. When it's published, it will set you back about 35 quid. Give it a couple of weeks, 2 or 3 weeks, and you can get it from Amazon for about 25 or even less. You don't need to buy it every year, once every couple of years if you're into that. There's a lot of stuff in there about, there's reviews of HF receivers, there's lists of, I'll just find the other things that are in here. Yeah, reviews of receivers, but it's also things like time signals, clandestine broadcasts, people that and if you go abroad, it's quite useful to have with you because it gives you all the local FM stations. If you want to get into listening to airplanes, the RAF publish a flight information handbook and an en route supplement. Shed loads of information about airfields in there, frequencies, everything. If you buy those, they'll set you back quite a few quid. These are an old copy that I got from a pilot friend, and these are 2017 editions, so they're a bit out of date. But I can recommend this book, the Airband Radio Handbook, by David Smith. He's an ex-air traffic controller. This is this is the 8th edition. Comes out about every 4 or 5 years, and everything you ever need about air traffic control, the abbreviations, all that kind of stuff. It's all in there. And of course, Practical Wireless. We haven't got Radio User now anymore. That used to be a good source of information. There is a radio ham, Delta Kilo 8 Oscar Kilo. You go onto his website. He's been doing this kind of stuff for years. He's written books on it. Very, very good. What I've put on here is things like the ITU. You can get a handbook on spectrum monitoring. And every few months they publish a monitoring report to tell you what's on the air. Ofcom, frequency allocations. The Maritime and Coast Guard Agency site, all the stuff's on there. The list of software, and on the back there's a list of useful websites. I'm sorry it's gone on so long, but I hope you enjoyed it.
Gentlemen, I think we can now.
Thank you.
Well,
Is that any good?
Don, thank you very much for that. Very, very interesting and informative talk on a subject. It's so interesting because there's so many things outside of the bands that people probably don't listen to. I mean, the last one, the
Stanek.
Stanek, yeah. That one, I've heard it so many times.
You will hear
bands, never knew what it was.
Yeah.
And never knew if you could decode it or not. So I've kind of, oh God, not that again, and gone past it.
Yeah.
So at least now we all know what it is.
Yeah.
But yeah, absolutely brilliant talk. Thank you very much for putting
Well,
that together.
what I'd like to do, if there's any interest in the club for any of this stuff, we can look, you know, on a Friday night, I can bring the laptop in and we can go through one type of signal in a bit more slow time. And we can say, like, this is how you decode this is what you're looking at. We've got a web connection here, so we can use an online receiver.
Perhaps the next one will be on the going into the VHF and looking at weather sats.
Well, yeah, I mean, there's...
Great. There you go. Thank you very much again, Don.
No problem. Good. I'm glad you enjoyed it.
If there's nothing else, please enjoy the rest of the evening. We'll have some questions, actually.
Jack, I was just wondering, you mentioned about the valves not being obtainable so easily. I thought the Russians were still making, building valves, just in case the EMP raises
They were. I mean, I don't know. They were, but I mean, the kind of valves that you're thinking of for the BBC transmitter at Droitwich are big. They're big brutes. They're great big, yeah, they're huge, great tubes. Nobody's making them because nobody's using long wave. Any broadcaster worth their salt are going to go online.
So to answer that question, the Russians are still making valves. There's companies like Svetlana and various others that are still doing it. There's also Chinese companies that are doing it. I think PS Vane is one. But a lot of them now are being made purely for the audio industry, because guitarists, for example, still absolutely adore the warm sound of a valve amplifier for guitars and for jazz. So there's a lot of that sort of valve manufacture being done, but very, very little in terms of transmitting valves. So Don's quite correct.
Okay, thank you.
All right.
The point to note on that.
A lot of those valves on transmitters, the BBC transmitters, they're actually water-cooled. So you get an idea of how big the thing is.
Yeah.
It's about the size of a dustbin you've got outside.
Which is, yeah. I've seen one.
I mean, this is old, and it, you know, I mean, AM broadcasting is old technology.
Oh, yeah.
You know.
It works.
But it works. When I had short trousers on, I worked for Echo Electronics at Kent.
I mean, I bet that was a sight to see.
Yeah.
Especially the short trousers now.
It was installed in the control tower free, but they were demonstrating. And the things we did on a Friday, we do a Friday check on the valves. What's the current going? And when it started to go down, somebody's job to change the
There's still
valve.
questions going on.
So you switch the bloody thing off, and I'm thinking, like, how long is it going to be before it nearly kills me?
But you're still here, Mike. That's the important thing.
Then I suddenly looked out the window and there's fire engines. Great, what's that?
Right.
But what I didn't realise, apparently you're supposed to phone up air traffic control to say, I am switching the beacon off. Nobody said anything about that.
Fair enough. Any other questions?
Ken, you had a question.
Yeah. What was our first book to be done?
This one,
No, the small one.
that one, or these. Oh, no, this one.
Yeah, I got a copy of
You've
one.
got a copy of that, yeah. Yeah, it's a useful book for
It is.
for UK stuff.
Yes.
Yeah.
Okay, gents. Any more for any more? No, in which case, thank you again, John. Enjoy the rest of the evening.
Thanks very much, guys.